Welcome to the fourth video in the Keystone series for review for 2018. In this video, we're going to look at some miscellaneous questions and then the constructed response for Module 1. For question 4, it says simplify that polynomial, 3x squared plus 3x minus 6 over 6x squared plus 18x plus 12. In this particular case, what we have to do is we have to first factor both of the expressions, the numerator and the denominator. We haven't learned this yet, but hopefully once you learn to factor it, it should be a little bit easier. So the numerator becomes, let's factor out a 3 first. It becomes 3 times x squared plus x minus 2. And our denominator, we're going to factor out a 6, becomes 6 times x squared and plus 3x, and 12 divided by 6 is 2. We can then factor this further. Our 3 and 6 becomes 1/2. So just by doing that, we've knocked out A for sure. And it looks like we've also knocked out D. So either B or C is going to be the correct answer. Since these are not the same expressions, we need to factor a little bit further. We have not factored trinomials yet. Please be patient. We'll get there. So the numerator becomes x plus 2, x minus 1. Our denominator, we have to remember to bring that 2 down. This is x plus 2, x plus 1. Because we have an x plus 2 and an x plus 2 in both our numerator and denominator, those will cancel. So we have an x minus 1 in our numerator, x plus 1 in our denominator, so C is the correct answer. Again, we haven't looked at factoring polynomials yet, but hopefully we will later on this year. So pay attention and we'll get back to that one. For part number 10, we have a part for a machine must meet certain length requirements in centimeters as shown in the inequality below. So it's the absolute value of 6.75 minus x is less than 0.25. What that means is that 6.75 is our middle number. And we're going to, so we have 6.75 in the middle, and on either side of it, so the difference between that is either minus 0.25 or plus 0.25. So we're going to take 6.75 and add 0.25, so we get 7. We're going to subtract 0.25, so we get 6.5. So what this means is that our thing, whatever it is, our part, has to be between those two end values. So A, the length of the part must be less than 7 centimeters. Well, yes, but not quite. It must be greater than 6.5 centimeters. Again, yes, but not quite. That's not the whole picture. Must be less than 6.75 or greater than 7 centimeters. It's got to be in between there. So it must be greater than 6.5 centimeters and less than 7 centimeters. That makes D the correct answer. Absolute value. Remember, how far is it away from that particular value? Okay, we can come back to that one again in class as well. Now on to constructed response. For this one, for number 13, we have small baskets of tomatoes are sold at a vegetable stand for $3 per basket. Large baskets of tomatoes are sold at the stand for $5 per basket. Only whole numbers of baskets may be purchased. A customer purchases a total of 8 baskets of tomatoes and pays $36. So we can write and solve a system of equations that models the number of small baskets X and large baskets Y that the customer purchases. show or explain all your work. So this is really, really important. Show or explain all your work. So please make sure that you're doing that when you're finally all done. So for me, this is a system of equations. So we're going to gather some information. So we have large baskets, we have small baskets, and we have some sort of a total. I'm just going to put things together in a table. So large baskets are Y, small baskets are X, and he buys 8 total baskets. If we look at the price, small are $3 per basket, large are $5 per basket, and the total is $36. That actually gives me my two systems of equations. So X plus Y equals 8. And the second one tells me that 3X plus 5Y equals 36. That's my total dollars. In order to solve this one, you can do either elimination or substitution. I prefer substitution, so I'm going to take the first equation. I'm going to subtract my y, and I get x equals 8 minus y. I can now take this, 8 minus y, and substitute that into my second equation for x. So I get 3 times 8 minus y plus 5y equals 36. And I'm going to simplify that. So I just distributed out the 3. I can combine like terms. So I get 24 plus 2y equals 36. Subtract out my 24. So I get 2y equals 12. Divide by 2. So y equals 6. So that tells me that the customer purchased 6 large baskets. If they purchased 6 large baskets, then we know that the total he purchased was 8. So he must have purchased 8 minus 6, or 2 small baskets. Okay, and that's how you do that one. Pretty straightforward. The next one, another customer claims that he can purchase a total of 10 baskets of tomatoes and pay $45. So use a system of equations that describes this customer's purchase to explain why the claim is incorrect. So let's set up our information the same as the other one. So we know he has 10 total baskets. So his small basket plus his large baskets must be 10. And again, we have 3x plus 5y equals 45. If we use substitution again, we say that x, right, we're going to change the first equation. X equals 10 minus y. Substitute that into the second equation. So 3 times 10 minus y plus 5y equals 45. We're going to distribute again. So 30 minus 3y plus 5y equals 45. Combine our like terms. So 30 plus 2y equals 45. Subtract out 30. So I get 2y equals 15, and divide by 2 to get y equals 7.5. Remember, y represents the number of large baskets. So can he purchase a half a large basket? No. So he cannot buy a half a large basket. And that disproves this customer's claim that he's got 10 baskets of of tomatoes because you can't buy half baskets. Okay, so make sure that when you go through the information and you go through the process, you think about what that answer means. For number 14, Kyle has $4 more than twice as much money as Lana. Lana has X dollars. Kyle does not have enough money to buy a video game that costs $56, but he has enough money to buy a textbook that costs $38. So we want to write a compound inequality that represents all the possible amounts of money Kyle could have in terms of X. So if Lana has X dollars, then Kyle, he's got $4 more than twice as much money as Lana. So twice as much money as Lana is 2x, and $4 more means plus 4. Okay? We also have some other information, and that other information has to do with video game that costs $56 and a textbook that costs $38. So those are our upper and lower bounds. In other words, the least amount of money he has is $38. The most amount of money he's got is $56. Okay? But he cannot buy that video game. So it's got to be less than 56. But he can buy the textbook. So it's less than or equal to there. So that's our compound inequality. Okay, we put Kyle's money in between and the two amounts of money that he possibly could buy things with on the outsides. The next question, what is the least amount of money Lana could have? So let me copy our compound inequality. Because remember, X has to do with Lana's money. We're going to solve this. So we're going to subtract 4 from everything. So we get 34 is less than or equal to 2x is less than 52. Divide everything by 2. So 17 is less than or equal to x is less than 26. So the least amount of money that Lana could have is the small end, so she could have $17. So that was just a matter of solving our compound inequality. So Lana has a whole number of dollars. So list the different possible amounts of money in dollars Lana could have. So remember, Lana could have anything between 17 and 52. Okay? So the different possible, 15 and between 17 and 26. So list the different possible amounts of money Lana could have. Well, she could have $17. She could have $18. She could have $19, 20, 21, 22, 23, 24, and 25. But remember, she couldn't buy that video game, so she can't have $26. Okay? And that's it. Remember to come back and review this video if you need more information.